Thank you for the introduction and inviting me. I'm excited to talk about the things that I do. So yeah, my name is Victor. I'm a computer scientist at the Argonne National Laboratory and also a research professor at UIC. Broadly speaking, my research interests are computer graphics, scientific visualizations, extended reality, and digital twins. And more specifically, what I do at Argonne, I work in the supercomputing division. It's called Argonne Leadership Computing Facility. And what we do is we build supercomputers. In fact, we have Aurora, which we released in January to the public. Aurora runs at 1.012 exaflops. So that's, you have giga, you have tera, you have peta, you have exa. So it's about 1 billion times faster, 1 billion times faster than your average computer. It has about 10,000 nodes, and each node has 6 GPUs. So we're talking about over 64,000 GPUs. And what we do is that scientists, they come in, they use the supercomputer, and they run simulations. And we, as a visualization team, we help them visualize their data. For those who don't know Argonne, we are part of the National Lab System. We're federally funded. There are 17 national labs. Argonne is known for being able to sustain for the first time controlled nuclear reaction with Fermi. That happened at Argonne. That's how Argonne got started. And then they moved and they did the Manhattan Project in Los Alamos. But today we don't do just nuclear. Actually, nuclear, we don't do a lot of nuclear anymore. We have supercomputers, we have a particle accelerator, and we do basic research on basic fields like physics and computing. So like I said, we have the scientists, they run these big simulations, and then we are the experts that will visualize their data. A lot of times that might mean static images or videos where they have a specific data set, they have a paper they want to present, or they're going to a conference, or maybe they want to talk to their stakeholders about the research that they're doing. So those are some of the images that I've created in the past, and I'm trying to use materials and lights and making things look more natural and using kind of like cinematic ways of rendering data. That's kind of like the production side of things, but I also do R&D. For the R&D, I'm going to talk about two projects. One is the digital twins for manufacturing. The idea behind this is that, more specifically, the project is for isotope production. So the idea behind this is that if you are dealing with isotopes, traditionally there is a hot box and there are gloves and you have to put your hands in and you need to manipulate the radioactive material. And this has not been updated from the beginning, basically, for 70 years. So how can you bring that to the 21st century? So we're building a hot box, we're building robots that will do that manipulation. Our part of the project is building the digital twin. So the digital twin is connected to the supercomputer. You go in the digital twin in VR, you perform the experiment, and while you're performing the experiment, the supercomputer basically analyzes the data and performs a simulation. So if you're pouring liquid through a filter, that's a simulation that's going to run on the supercomputer. You're going to see the result in your VR headset and the digital twin, and the results of the robot you're moving around. And then you teach the computer how to do that, and then you can run that autonomously once it learns how to do that. Second project is about building an AI scientific assistant, more specifically for data analysis and visualization. In this case, you can, again, have the scientists that run these big simulations. How do they analyze the data with the AI scientific assistant that we're building? So you go in VR and you just talk to it using LLM, and you ask questions, and it's going to help you build graphs, build visualizations, and maybe even come up with new hypotheses. But the idea is natural language, VR, and doing science. So those are like the two newest things that I'm looking into.